रिफ्रेश करोगे चालू ग्रीन होगा तो ही चालू होगा ऑरेंज होगा तो म्यूट
A very good afternoon to all of you. Welcome back. We'll be kickstarting our first plenary session on STI Vision 2047. This is also to make an announcement that we will be launching the Science Expo shortly. To begin today's session, I would like to tell that the idea behind this session is to discuss various issues and challenges in state and center coordination on STI, and also to define the future pathways in STI. With this prelude, and to felicitate our dignitaries on the dais, I request our moderator, Professor A.K. Sood, Principal Scientific Advisor to the Government India, to felicitate Dr. S. Chandrasekhar, Secretary, Department of Science and Technology, Government of India. We welcome Dr. Rajesh S. Gokhale, Secretary, Department of Biotechnology, Government of India. We welcome Dr. N. Kalayaselvi, Secretary, DSIR, and Director General, CSIR. We welcome Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences. We welcome Shri K.N. Vyas, Secretary, Department of Atomic Energy and Chairman, Atomic Energy. We welcome Shri S. Somnath, Secretary, Department of Space and Chairman, ISRO. Now I request DST Secretary to felicitate Professor A.K. Sood, Principal Scientific Advisor to the Government of India. To initiate today's session, I request our moderator, Professor A.K. Sood, to take the floor and begin the session. Over to you, sir.
Good afternoon to all of you. It is indeed a great pleasure and a privilege to be having this panel discussion in this very important conclave with six brilliant panelists who's who in Indian science, who will tell you different perspectives of their department and what can be done in collaboration with the states. And some of it is already happening, but they will also elaborate what the new plans could be. Now, as moderator, I thought I'll take 2-3 minutes just to flag 2 points which may not be mentioned, but we can have in the panel discussion. And this arises from the key challenges list which Dr. Akhilesh Gupta had given to all of you in the pamphlet. And that is the R&D funding in science and technology. We all know that it is about 0.7% of GDP, and there has been a long-standing demand that it should be increased. The only thing you have to notice is that the private sector contribution in this has remained very modest from 0.15 to 0.2, and that has to be attempted. But in the context of states, I just thought a new development which has come in the form of FDI in R&D, foreign direct investment, and this year India has seen a huge growth. Now this FDI in R&D can really be pursued by states. It turns out that from October 2019 to March 2022, we had an FDI of about 3,500 crore rupees. Now, out of this, only 12 states have been successful, and only 5 states have bagged 96%. I will not name these 5 states, but we have all the data which is authentic. So that tells that a lot more needs to be done by the remaining states and union territories to look into how to attract FDI in R&D. So this is something to think over when we have the panel discussion. And the second thing, which is again connected with our office and many ministries here, is the emphasis on this One Health mission, which includes human health, livestock, wildlife all together, where many ministries, including DBT, Ministry of Health and so on, are participating or are already doing it. And the effort of our office, when we discussed in PM Strike, is to bring synergy and see where are the gap points which we need to fill. So these two, again, in this, the participation of state will be very critical, and two states, Karnataka and Uttarakhand, have already made a beginning in this One Health mission in their states. And I would suggest when we talk of state-state partnership, we should, other states should see how they can connect to this One Health mission. So with these two, I will not stand between you and other panelists, and I have great pleasure in inviting Dr. S. Chandrasekhar. Just a small announcement that we will have very lively discussion after the 6 presentations, each lasting about 5 minutes or 7 minutes. They will have the audio-visual presentation. Please note down your points, and after the 6 presentations, we will have about half an hour or even more for discussion and interaction. So let me get this going. And first, Secretary DST, Dr. S. Chandrasekhar, to tell his vision of center-state interaction.
Slides on, please. Thank you. Honorable Minister for Science and Technology and other dignitaries in the audience and fellow panelists, on behalf of all the panelists, I thank Professor Sood for giving us a template that all of us share 4 to 5 slides each in the beginning, and then we go for the discussion. So I'm waiting for the slides to come on. Yeah, thank you. So while we have been discussing from the morning, I think it's there already. Yeah, but we are blind. Oh, okay. Yeah, okay. Today, Honorable Prime Minister has already spelled on the importance of how the states connect with the central research organizations and also ministries on taking the technologies forward and making India truly a global leader by 2047. So if you look at the slide today, what DST has been doing currently is we connect to the state councils, and we do work with all the 29 state councils and make sure that a small grant is given, and they make sure that they connect in turn to the local colleges and also research institutes. While this is a small activity we do, the objective of DST has been to see how the states partner with DST in toto. And again, I think as Honorable Minister was telling during the Ministers' Conclave, you don't tell very jargon that I'm trying to understand the protein structure or trying to see whether benzene is aromatic or not aromatic. But you will be able to convince your grandmother that what I'm going to do is useful to the society. You tell that I'm trying to make a drug which will cure your headache, or I'm going to make a drug that at your old age, you will get a better walking stick than what currently you're using. That's the science we need to work towards. Next slide, please. So just to give you a glimpse of what currently DST has been doing in the state science and technology programs, I'm just giving you some statistics for the last 5 years. So we have supported about 450 scientific manpower for the states. And I'm also happy to announce that Gujarat, Himachal have excellent STI policy, where IPR policy is already done by Rajasthan, Gujarat, Kerala, Karnataka, and West Bengal. So some states are very proactive, but I urge on this forum, all the 29 states and union territories, that please align with the Government of India science programs, and we also are willing to learn things from you. Sometimes, many a times, the science, what we do in the national labs, many states will not even know what is happening. For example, while we were in IICT as a director, we made some technology which may be useful to some other state, but only Telangana would know what we were doing. So it's time that this platform, what Honorable Minister and Honorable Prime Minister have advised today, that this is the first forum where all the states are here trying to understand each other's problems and what solutions we can offer to each other. And again, I don't want to read this slide in toto, but this is the kind of engagement our department has done in the last 4 years. Next slide, please. So what currently DST is planning to do is basically the catalyzing the overall STI ecosystem in the states through R&D strategy for societal and commercial applications. So this is something very critical for our ministry, and this is our vision statement. So I request all of you to connect to DST through our various officers and see how you could take advantage of our ministry. Also, I think academia-industry relationship is very critical. While today we are connecting to the state secretaries and national secretaries who are sitting on the dais today, but we also would like to have a forum where all the industries who are working in various states also connect to us, so that we will have really a public-private partnership and see that whatever research we do in the laboratories reach really the masses. Also identify and demonstrate appropriate technologies against the state needs. Sometimes, for example, my state in Telangana or Andhra or somewhere in Gujarat, for example, if they develop a desalination technology, maybe this technology is required for some other state, but they will not even know the technology is available. So these kind of events certainly will enable us to know what kind of technology is available with each other. Again, the initiation of the new patent information centers in Puducherry, Andhra Pradesh, Bihar, Meghalaya, and re-establishment of patent information centers in Jammu and Kashmir is one important contribution we have done recently, including Chhattisgarh. As I told you in my opening statement, we continue to support the state councils, but we are eager to work more closely with you. If required, little more grants can be given in such a way that state councils really get rejuvenated. I only urge the state leadership who are in the audience today that when DST or any of the ministry gives a small grant to the state councils, we request the states also to contribute a matching grant, so that also the R&D investment, what we've been talking, that we have to go from 0.7% of the investments into 2%. Certainly states will play a very important role, and we urge states also to participate with equal commitment like what national labs have been doing. Similarly, if you look at the startup ecosystem, DST, DBT, and other agencies within the Government of India have been funding many startup programs, and one of the largest T-hubs, which is currently in Telangana, which is the world's largest hub, is also funded by the DST under a Nidhi program. And also in Gujarat, currently where we are here today, Government of India through Nidhi program has given funds to make this unique organization here in Gujarat. While we are happy that Gujarat spends such much more money than what states spend, what center gives to Gujarat on research and development, while been talking to some secretaries of Gujarat government, they're also coming up with 4 unique centers investing 100 crores each to have laboratories on their own. I think this is a very unique culture, and we do believe that every state, if they start having at least 4 or 5 labs which compete national labs, and that would be a great competitive spirit which our country can develop. And recently in Madhya Pradesh, when there was a state-level STI ecosystem meeting happened, where we invite all the state leaders who got money from DST and spend money on the council activities, and we made a small compendium, and I tell you that in the next few weeks, the inputs of all these states has been put into a small compendium, which we'll share with all of you. That also will give you the kind of activities DST is currently doing with the state councils. But DST is open to discuss with all of you and see how DST engages with all the states and see that India truly becomes the world leader in science and technology. Thank you. Jai Hind.
Dr. Chandrasekhar. So may I now invite Dr. Rajesh Gokhale, Secretary DBT, to share his thoughts.
My namaskar to all of you. Thank you very much, Professor Sood, for this opportunity. Can I have slides, please? So what I thought I would talk to you about is how bioeconomy would be a driver for the growth in the Amrit Kal, as our Prime Minister so profoundly actually gave us this submission today of doing this actually. Can I have next slide, please? I think just before I proceed, I just want to say, you know, the kind of successful stories the Department of Biotechnology has done in last couple of years. And I always say, you know, if we can deliver in wartime, we should be able to deliver things in peacetime as well, actually, with same alacrity and same kind of fervor and passion. As you can see, almost 4 different kind of vaccines that have been enabled, which were all developed in various industries. But in fact, when we celebrate the end product, we always forget the innovation that is involved in different kinds of activity that are required, which involves setting up clinical trial sites, engagement of people, doing immunoassays, carrying out biological systems, making animal models to be able to test. And I think all of these, in fact, have been nurtured by Department of Biotechnology in various sectors in collaboration with BIRAC, which is another SPSC, to carry out. And I think you can see the biggest achievement of all this all across the world that people talked about is that COVID-19 vaccine has saved about 20 million lives in about 1 year, actually. So it's one of those most very successful stories, actually, and I think it's important that we continue to do this in future of bioeconomic process. Can I have next slide, please? So what are the key highlights of the bioeconomy report this year, actually, and where do we stand? I thought I'll just start there. So India generated about 219 million of bioeconomy daily, which is about $80 billion of this in 2021. There are approximately 3 biotech startups that got started and were incorporated every day. So about 1,128 startups, and I'm pretty much sure they can grow even much faster. Administered about 4 million doses of COVID-19 vaccine, which is around 1.5 billion doses in 2021, and conducted about 1.3 million COVID-19 tests, which is about 506.7 million tests done. So you can imagine the numbers that we are talking about in our country are absolutely astonishing, and in fact have provided us a leadership in this space for the world. And the unprecedented R&D investment of biotech industry is actually completely never heard before for. Next slide, please. So how do we capitalize on this? And if you really look at this set out national bioeconomy strategy for 25 years, that's what we really need to do. And one needs to engage with states and create awareness of the potential and set targets for bioeconomy. For example, Karnataka state has set a target of 50 billion by 2030. Similarly, I'm pretty much sure Gujarat documents, which was recently announced, biotechnology strategy, also committed on some numbers. I think if we do this, the whole country will grow as a perspective to look at in a bioeconomic scenario of how well we can perform, and we'll be able to consolidate these activities around. Can I have next slide, please? So if you look at the real strength in India is what several honorable ministers who were in dais talked about their regions, actually. Is the diverse biodiversity and bioresource management is probably one of our major goals of how to really look at various zones in the country and in fact manage these bioresources such that they provide maximum amount of economic model for each region for them to grow as we proceed into the future of this. You can see we have an arid zone economy, forest bioeconomy, Western Ghats, Eastern, and obviously the Deep Ocean Mission, which is actually the Earth Sciences Ministry is dealing with it, is the way to look at in future of the way the bioeconomy can grow. And in fact, biological systems and biotechnological techniques and methods can work through all these processes as we proceed ahead. Can I have next slide? So this is one of the mechanisms that we will dwell with this actually. If you want to use efficient use of bioresources to produce, these are all the areas that all of you are aware of are critical to look at. But even if you look at one simple example that I'm trying to give you here for the various waste to value for the crops, if you look at different parts of a country, for example, kharif rice, wheat rice, cotton, sugarcane, and rabi, in fact, they all get produced and they produce as biological waste. And a lot of this biological waste, in fact, can be converted into useful material if one actually standardizes industries and fermentation technologies in this space of areas, such that the value chain can get added and can get created. So you can see every state, in fact, can empower themselves, be able to catalyze these activities. Can I have next slide, please? And the technology can be common because that continues to carry out. And therefore, what one can think of in future, next 3 years to come, is of biomanufacturing through these synthetic biology routes where enzymes and engineered strains and various mechanisms can be used to carry out these activities. Can I have next slide, please? And you can see the raw material is already available on the fields and on the agricultural lands, which can be utilized, which is already providing the value. This is something that Professor Sood mentioned, actually of very critical importance, One Health and infectious diseases. You can see the number of recent episodes in different parts of the country that have in fact come up, and now scrub typhus and other kind of things that are coming around actually. There's a constant eruptions of various kinds of these activities that will emerge in different parts of the country. And in fact, the transmission to humans is but for natural, of course restrictive, but is natural and sometimes can take an epidemic proportions actually. So how can one control these kind of activities? By developing best diagnostics, by using vaccinations, and by developing markets around this region would be very, very important to look at. Next slide, please. So what Department of Biotechnology has been able to do is actually coordinate along with Health Ministry a large activity which is of genomic surveillance called INSACOG actually. And what this has done is across the country, samples have been collected and more than 2 lakh genome sequences of coronaviruses have been carried out, deposited in various databases for people to analyze. And this sets a tone of how we look at epidemiological perspective in future of our country. And in fact, tuberculosis is the next one that we are targeting now. And very soon, the tuberculosis genome survey will be done to understand the antimicrobial resistant patterns, to look at the available strains that are present around. And the plan is to do about 25,000 to 40,000 genomes in next 1 year to come, actually. And I think that will set stones to look at which are the regions that have higher amount of strains that are in specific antimicrobial resistance targets and another kind. Finally, I would just like to talk about artificial intelligence and the chronic diseases that we all suffer from, in fact, are very complex features of our life. And the only way one can actually create better diagnostics and better mechanisms of health recovery is to, in fact, adopt to these new technologies of artificial intelligence and others. And therefore, the predictive healthcare goods can, in fact, be developed in a much faster and an efficient way. I think I'll stop here and thank you very much for this opportunity. I think we'll be happy to discuss around this areas. Thank you.
Thank you very much, Dr. Gokhale. Wonderful presentation. So now let me request Dr. Kalai Selvi, Secretary DSIR and Director General CSIR, to share her thoughts with us.
Namaskar. Leaders on the dais and off the dais, next-gen leaders, responsible citizens of this nation, good afternoon to every one of you. I'm extremely thankful for this particular opportunity, especially to the Department of Science and Technology and Professor Sood, and I'm here on behalf of Council of Scientific and Industrial Research. So next slide, please. So today I'll be just sharing some of the thoughts and some of the areas in which we from CSIR, we believe that we'll be able to cater to the requirements of almost all the states within this country. So we have around 37 laboratories in this particular country, and we are touching upon 26 cities of this India. And we are offering our own service to this country in 2 forms. I would say capacity building in terms of research and development, and the other one is capacity building in terms of technically trained HR. In that way, we from CSIR laboratories, we have some options with respect to bringing in the next generation leaders by way of offering some UG courses, because 2 very unique courses we are offering from CSIR. One is chemical and electrochemical technology from Csir. The other one is leather technology from CLRI. So these are the 2 UG courses which are very, very unique and which are being offered only by CSIR in this country. And we are coming up with new PG courses, IDDP courses, and we are doing a lot of research related programs through our one window called ACSIR, which is Academy. And so by means of this, we are able to cater to this particular country in terms of creating or nurturing the second line leaders. And when you just talk about the areas in which CSIR can really look into the problems of the states, we are approaching the states and your requirements through 8 different areas. We call it as thematic directorates. So I have given what are the thematic directorates here. So starting from energy, water, agriculture, metals, minerals, mining, healthcare. So these are the areas in which we are offering our service in the form of research and development. Next slide, please. So this, I'm just going to talk about the services of CSIR under 2 headings. One is what and all we can really offer to urban and industrial sector, and what and all we can offer to the rural society of this country. So when you just think about this urban and industrial, so I have just given you some kind of an example, whether it is related to transport with respect to road transport or air transport. In both the cases, we have a lot of technologies which are available with us. So I have given some good examples here, and we are able to these days give you the last mile connectivity also, for which the recently established or demonstrated steel slag road that was laid in this country is a good example. And all of you are aware of this programs, which is a fuel cell run bus and a car. So this particular technology will also see its version 2 and version 3. And soon we are very, very hopeful that this country will have a lot of e-mobility, both in terms of our Mission Hydrogen program, as well as with the battery operated and hybrid electric vehicle operated e-mobility. And the other one is known to you, which is our biojet fuel. Even the used oil could be utilized as a biofuel, and we have also demonstrated that technology. Apart from that, we have many success stories in core chemical, agrochemical areas also. That includes, next slide please. That includes coal to methanol and DME related technologies. So this one slide will give you a glimpse of what and all CSIR is able to offer to the complete rural population in this country. So if you just start from the medicinal, aromatic and economic plants, yes, we are doing it in a big way, starting from Jammu and Kashmir, Leh, Ladakh, Mizoram, Manipur, Northeast. And in the case of Northwest, we are doing it in a different way, where we do water mapping, water management. Many areas are common to the entire country, and certain areas I'm just showcasing that they're pertinent to the individual states. And when we talk about the rural water technologies, we are able to do it under 3 different headings. One is water mapping, the other one is water management by means of through quality control, and the last one is desalination of water. So these are the 3 areas by means of which we are trying our level best to just say that yes, we can come up with a good quality water management. And connectivity I have already talked about. And mechanization of agriculture also, we have number of, starting from small tractors to post-harvesting machinery, we have number of technologies available. So states which are really looking for this kind of intervention of technology or some kind of an automation in the field of agriculture, be it in the form of smart agriculture or in the form of mechanized agriculture, CSIR is really welcoming you, and you can please take a start from today onwards. And coming to the other one, the precision health and all, yes, we also work in a good way along with the DST as well as with the DBT. And as consortia, many times we have proven our strength. And recently, CSIR has been even awarded Golden Peacock Award for the kind of special efforts that were made during this COVID period. And coming to the skill development, as I already told, we are not only coming up with creating the technically trained HR only through academics, but also through skill development. 2 very important programs. One is a skill development program of CSIR, wherein the 10th class pass to 10th fail students up to the age of their PhD, we are having different levels of skill development programs available. And as a part of the skill development program, we are also giving some kind of specially trained courses as well as trainings to even industries also. The second important program with respect to the bringing up our own second line leaders is Jigyasa. So Jigyasa is a scientist and a student connect program. So we touch upon the lives of the school children, starting from this Atal incubation labs, and we are also giving them a lot of opportunities by way of encouraging, by giving do by yourself kit also. And food processing and agrochemicals also, if you just visit the few of the stalls here, you can very easily understand where and all we are playing a major role. Next slide, please. So this is one good example I can say, because this is a dedicated slide for the rural development. So starting from this purple revolution, because morning also the Honorable Minister of Science and Technology was talking about the purple revolution. So this purple revolution has really raised the income of the farmers, starting from 20,000 per month per acre to 2 lakh per month to per acre. So that is a tenfold increase in their income. And the other one is seaweed cultivation. So the coastal area, the female population, they are getting lot of employment opportunities in this case of seaweed. And in the case of lemongrass, actually we have created a new history, because till maybe last 3 or 4 years back, India was really importing a lot of lemongrass oil. But now we are rich with lemongrass, and we started even exporting lemongrass oil. And last year we exported 600 tons of lemongrass oil, and this is one of the success stories that I can tell you here. And similarly in the case of apple, once upon a time this apple was requiring a very high temperature, and it was requiring a long processing time. We have reduced that time also. So these are the science and technology related intervention by means of which we are making many of the technologies as farmer friendly, human friendly, or even women friendly, or easy to adopt kind of technologies, by means of which not only they also get themselves really encouraged to come up with this kind of a technology, but also we are helping them to increase, to get some increased income. Next slide. So this is another success story. This is our societal impact on CSIR, because morning also Honorable Minister was talking about we have to come up with new areas and innovation. This is one good example of an innovation. This is a Samba Missouri rice. So it is having two important things. One is it is able to give you some kind of a protection against this bacterial blight, and other one is this is diabetic resistant also. So this is one example I gave you. This is a typical one. We have number of other products that are showcased in the few of the stalls. Next slide. I think that is the last slide. Yeah, this is the Jigyasa program, which I already told you. Number of avenues we have created, especially in the recent years, by means of which we just want to tell the second line leaders that, yes, we are here to handhold you. So whenever we are doing this kind of a Jigyasa program, students are really getting motivated, and we could really see the kind of excitation that is coming up in the recent days. Next slide, please. So if at all you want to have more idea and more knowledge about what CSIR is doing, or what the states can really approach CSIR for their science and technology related help, you can visit this particular site itself, wherein everything is available in this one particular site. So for more details, once again, I'll be more than happy to answer any of the questions towards the end of this particular discussion program. Thank you one and all. Thanks again for the opportunity.
Thank you very much, Dr. Kalai Selvi. Now may I request Dr. M. Ravichandran, Secretary MOES, to share his vision.
Thank you, sir. Very good afternoon to everyone. As you all know that most of the people may not be knowing what is Ministry of Earth Sciences doing. Of course, what we are doing is basically in all state of matter, either gaseous state or liquid state or solid state, both solid earth in terms of ice or land, we are working on in the entire earth system, Mother Earth. Basically, we try to understand the Mother Earth and try to produce some science and services from the Mother Earth, what we can do that. Can you? Okay. So the first one is basically the atmospheric science, because when we are talking about Earth system, it is combined with a total system of 5 spheres, maybe atmosphere, hydrosphere, geosphere, cryosphere, and its associated biosphere. So all the 5 spheres, how we are holistically look at it, how it interacts each other, that is what in different places, how we are doing it. So in the atmosphere, we are basically trying to understand the weather phenomena, not only weather from the present state to climate scale, from the long-term different time scale. We try to look at it, weather phenomena. And in the ocean area, we are providing, try to various services from the ocean. What are the services available? Maybe I will list out what are the services. And similarly, from the ocean area, we try to explore or develop a technology for both living and non-living resources, how to harness this sustainably as well as environmental friendly. How do we harness that? That is what we are looking at in the ocean. And the third one is, of course, the fourth one is earthquake. Basically, we are monitoring the earthquake presently, and we are maybe in the few decades or some, our idea is to how we can go for a early detection or early prediction of or at least the early prediction of the earthquakes. That is what we are aiming at. But presently we are trying to monitor the various earthquakes. Even each city at the level of 3 magnitude, our aim is to go for it so that we can go for the city development plan, where we need to urbanize development of city, what are the areas of earthquake magnitude, and how do we build, where we need to build the different types of building, where we should not. So that are all advices we are providing. And the last one is basically we are exploring the scientific exploration of all 3 poles, Antarctic, Arctic, and Himalaya. Next slide, please. When you are talking about the ocean, so this is what we have recently started with because of the ocean resources. I think many countries have explored most of the land resources. Now we have to harness some of the ocean resources, so both living as well as non-living resources. So presently we are providing many of these services. Presently, for example, potential fishery zone advisories. That means where the fisherman has to go and hunt the fish, so that we can save the fuel as well as time and effort. And when we go for the fishermen, go for the fisheries and other things, and also at the same time we provide the weather condition at the ocean weather, how it is the weather condition, whether it is safe to go there or not. That services also we provide. And the third one is basically we are also monitoring the various marine pollution, how the health of the ocean in our waters, whether the fishing conditions and various chemical traces, how it is present, we monitor and provide the services. And also we made some of the salient desalination technology development, especially in the island. It is a unique one. It is in the world. We are not doing for any reverse osmosis or anything. Basically, it is a temperature gradient. Using the temperature gradient, if you have any temperature gradient of water about more than 20 degrees centigrade, or the salinity of more than 20 PSU, we will be able to harness the energy of what is called energy as well as water. So basically, we are aiming from the ocean, but not only energy, but also water, and also various living and marine mineral resources we are trying to harness. And also, our main objective is, of course, we have to make a framework or the blue economy. Under that, basically the country's GDP, how we can improve using the blue economy, how much we can improve in various sectors of the ocean sector. For that, what are the activities we need to do? So one of that activity is a deep ocean mission. Maybe that we will discuss elaborately in tomorrow's, but mainly to harness the ocean resources for the benefit of the society. And finally, of course, you all know that this particular state, the Kalpasar project, we are making it a big Kalpasar dam for many purposes. It is not only for the road connectivity, but also water resources and many other ecosystem development. We are also planning and developing the system in the Gujarat. Next slide, please. When you talk about atmospheric science, of course, this is atmospheric and earth science, solid earth. When you talk about atmospheric science, we go with the weather. So you all know that weather, it is not only the present day weather, but also in the few days weather and medium range, as well as we go for the monthly and seasonal and yearly and climate scale. So we are going for a different scale, but I know that the agriculture people needed is the medium range to monthly scale forecast, that we are working on it. But you all know that this forecast is greatly improve, or the importance of the forecast improvement is mainly for the 4 components. One is observation, understanding, and whatever you understand, you model them and try to forecast them. So the observation capability is very less. That's but many of the coastal states, or not only coastal states, many of the land or maybe states, different states are observing. So my request is, if you want to have a better forecast in your state or in your district or in your place, if you have any observations, that also you can share it so that we can have a better forecast. That is the best model is Karnataka state. Karnataka state is having a number of observations in the weather observations, and they contribute to the center so that we are able to provide better forecast for Karnataka rather than other states because of the number of observations are more. And also early warnings, as I mentioned, for earthquake, early warnings and landslides, flooding, and microzonations, all these type of various services we provide. So essentially what is our objective is, from the Mother Earth, how the science can provide to the services, especially science to services or science to society. So that is our main job. Next slide. So these are some of the things I requested from the state. Of course, if you have the data of any of the particular geo information available from your state, or you need some of the specific information from the Mother Earth, these are the information we required from the solid earth, or maybe in the earth, so that we can always come prepared for the together for the benefit of particular state or the region. We can try to provide better services of all the Mother Earth. Thank you very much.
Thank you, Dr. Ravichandran. Now may I request Shri K.N. Vyas, Secretary DAE and Chairman Atomic Energy, to share his vision.
Thank you very much, sir. Dignitaries on the dais and off the dais. I think there is going
Let
to be...
us sort this out.
I think this format is wide format, that's why this problem. Okay.
No, I think because in last talk also it had a issue.
Yeah, I think...
Okay.
I think I'll start, sir, and of course, without visual it will be difficult, but
It is flashing for some reason. No, but question is they cannot.
maybe I think, sir, I'll start.
See,
Yeah.
because it is made in 4 parts, the screen, and the synchronization is the issue. See, this has 4 parts. Can you?
Yeah, sir, if you permit, I think I'll start. Let us see whatever is visible.
Okay.
Yes, sir. So, maybe next slide, please. See, number one, this is a very comprehensive agenda of this conclave. What I have done is I have selected just 2 topics in which Department of Atomic Energy has been able to contribute, which can be of use to society, which is namely agriculture and water technologies. I will describe few examples which can be of help for various states for implementation. Their entrepreneurs can take these technologies and it could be useful. Next slide, please. Number one is related to agriculture. As you all know, when a particular seed is subjected to irradiation, the genetic structure is slightly strained, and as a result of that, some genetic changes take place. These are, some of the changes could enhance the properties, some of the changes may not enhance the properties. So if you see groundnut seeds, if they are irradiated in the gamma irradiated on the leftmost side, depending upon the dose received by the seeds, the growth of the plant affects. If the dose is high, the growth is relatively less. And finally, the types of groundnut seeds that you get, it has different characteristics. Some of them have changed the color, some of them have increased the size. Internally, some of them may have more, say, oil concentration and so on. And then finally, out of all these trials, scientists select some of the seeds which are found to be having all good characteristics, and then finally the state varietal release committee for the seeds, they accept particular variety for acceptance by the farmers. And I would like to bring to your kind notice here is, number one, there is no residual activity because it has gone through so many generations. Even in the first generation also there is no radiation radiation, residual radiation. And second thing is, this is not genetically modified, where when in a parent gene, some foreign gene is not introduced, it is the same gene structure which gets slightly tweaked randomly based on the radiation dose received. Next slide, please. Generally, there is the feeling that if the plant size is big, it may give us more yield or it may be better. But if you see this photograph on the left hand side, this is the original parent variety. The one on the right hand side is the mutant variety, and you find that the height is less. As a result, but still, even though the height is less, it has got higher yield, lower time for maturity, and it has, I think it's not visible here, and ultimately it is an advantage, and as a result of that, it has been accepted for by the state of Raipur, IGKV state of Chhattisgarh, for adoption by farmer. You see here the parent variety is taller. In case of wind, the whole crop may get lodged and the farmer may lose. In the right hand side, whatever is the photograph, it shows that the crop is really going to mature. It is not get affected because of weather condition. Next slide, next please. You see here genetic changes which may happen. The entire field for mustard, it is dry, but there is one plant which is green. So it has got some good characteristics. The agricultural scientists of BRC, they see whether this particular plant is having better properties or not. Next please. This Trombe groundnut variety is very popular among northern Karnataka, Maharashtra, Gujarat. You see here in last crop, it had got, this is 39 stands for TG39, and the farmer got extremely good prices. It was the highest record price in Gondal yard. Next one please. Like this, BRC has released 55 varieties. Most of them are in oil seeds. These varieties, they have higher yield, early maturity, disease resistance, edit compatibility. It could be combination of one or two characteristics, and finally it is approved for use. Next slide please. Apart from the improvement in the crop, irradiation helps also in preservation of food, specifically if it is non-vegetarian food. So one advantage of radiation is the food can be irradiated even after packing. So there are many food parks, they can adopt this particular thing. It can be a packaged food, it can be subjected to irradiation, and then it can be phytosanitized. Advantage is there are absolutely no need for using preservative which may be harmful to health. Next please. In India, there are 25 food irradiation parks. You see they are concentrated in the western and northern zone. Rest of the country also has very large produce, and this type of irradiation plants can be coupled with the food parks. For example, China has 109 such food irradiation facility, USA has 50, while India, even though it is having so much of agricultural produce, it is relatively having lesser number of irradiation facilities. Next one please. One more development which was done by BRC in DAE, one was development of hydrogel. What you see here, this hydrogel, it has about 450 to 500 times capacity to absorb water. And another thing is hygienized sludge, which is a organic carbon rich sprinkled with bio-NPK fertilizer. Lot of credit goes to Ahmedabad Municipal Corporation, who has adopted this particular technology, and plant is operational. Using these two products, next one please, some trials for plantation was carried out. A small plot, very small plot, what you see in Google map in Asola near Delhi was given to us. If you see October in 2021 October, the plantation was carried out. What you see Dr. Sarita Jain, who had from Forest Research Institute, who had helped us in plantation. You see on November, I'm sorry, there is a mistake here. It should have been October 20. November 21 and September 22. It is after 1 year's gap. So growth is quite good. And if you see, as of now, just this month, the growth is extremely good. Forest Research Institute is extremely happy. This particular aspect was indicated to the Honorable Prime Minister also. So this year, about 1,000 hectare land we have planted with collaboration with Gujarat Forest Research Institute, about 1,000 hectare land. This particular trees have been planted. We will see whether that is coming all right or not. And the water requirement is roughly half because of the presence of hydrogel. So that is how it is quite advantageous. Next one, please. One additional work which is done in DAE is the water hydrology part of it. That is using the isotopes of hydrogen, that is hydrogen, deuterium and tritium, and understanding how the proportion changes in various locations. We can find out how subsoil water movements takes place. I would say, crudely speaking, it is something similar to doing angiography type of examination. So you find out how this radioisotope variation changes, and one can identify which are the suitable locations for making recharge bore wells. This has been extremely successful. Next one, please. In the state of Uttarakhand, in early 2000, a very systematic effort was carried out, specifically in Chamoli district, and lot of credit goes to Professor Joshi, who was the university professor there, and he sort of made us, I would say, he guided us how this work has to be done. And in early 2000, water in this region was known as BRC water. What you see, Dr. Gursharan Singh, he was the person who had spearheaded this activity. Next one, please. In water technologies, we have extremely good brackish RO plants, which is totally indigenized. Membrane is also manufactured within India by various suppliers. The first plant was put in Maharashtra at village Somthana in district Hingoli. It is a water ATM. It gives, it takes brackish water, removes arsenic, iron, depending upon whatever are the impurities. And as of now, about 14 such water ATMs have been put in. The people find it extremely good. About 5 rupees they get 20-liter water, and they are. It is quite. We have found it very suitable for a village having a population of about 1,000 or so. Next one, please. One part related to water technology is technology has been developed. Usually the sewage water mass is floccular in nature, it does not settle so easily. Based on this technology, the floccular mass gets converted to granular mass. Next one, please. And it settles very easily. About 2.5 years back in New Delhi at Indian Rail Vikas Nigam Limited colony, a small 40 KLD plant was constructed, and it has been working very nicely. Next one, please. Typically, if you see, compared to normal activated sludge processing, for the last one is, you see the area is about 1/4 and power requirement is about 40% of typical that multi-bed reactor. Next one, please. Recently one work which has been completed is of effluent. India is having large number of dyeing and printing facilities which are as part of MSME. So what you see in the bottle there, just couple of minutes. What you see on the left hand side is a impure water. What you see on the right hand side is water which has been cleaned. In Jaipur, this particular plant has been put in, and Jodhpur right now the trials are continuing. Next one, please. Fine. Thank you very much. Most of this technologies has been developed by BRC, which is the mother unit of DI. Thank you very much.
Thank you very much, Vyasji. May I request now Shri Somnath ji, Secretary DOS and Chairman ISRO, to share his vision.
Good evening, all of you, and thank you for this opportunity. I would like to present Space and States, In fact, the space between the work done by the National Space Agency and the states has to be reduced. That's the goal. So let me go to the first slide. Just to tell in summary, what is the current position in this domain? Most of you may be aware that we have created the indigenous capability in space system to build and launch satellites from our own soil. And we have 50 plus satellites currently operating, providing communication services, the Earth observation services, navigation services, as well as the science missions. But more than the infrastructure I am talking about, what we have created in the application side is more important. And this is what I would like to stress today. In the domain of governance, societal usage, in business, as well as institutions that you have created in space is much more interesting to you, especially when you discuss the collaboration with states. In the governance, there are central schemes which the space is continuously providing services, and as far as societal applications connected with other ministries and departments continue to be the Department of Space's work in various actors, which I am not going to list or speak now. Equally important is while we were working in governmental sector, in institutions, we have been continuously working in the industries and private entrepreneurs to develop the space ecosystem in this country. Today we have 50 plus industries, 450 plus small scale manufacturers, capacity building, the service sectors, all come up now. So we are talking about a change in approach in Department of Space today. We also have institutions, incubation centers, startups. Probably you can find more details in our website later, so I won't go through them now. Next slide, please. We also have created a roadmap for 2047. I think this is very important when states looks at the space-related activities in their current states. The most important point is the space-based economy is now coming into place, especially the digital economy where we look at the digital connect primarily through the communication network, Earth observation network, the PNT services, all getting merged into one system in which space become an integral part of it. And driven from this are the business opportunities as well as the technology development of requirements. So it goes from the demand to the requirement in different layers. I think this is what we'll have to understand. But I don't take time to explain to you each of this at this point in time. But please read and understand the economy aspect of space ecosystem is really promising for many of the new entrepreneurs to come into this domain. Let me go to the next slide. Specifically to tell what are the avenues for space for the states to work in. And some of the examples are very worth considering for all of you. For example, the work done in the Maharashtra on the Maha Agritech activities. Also to look at how to have more crops yield at certain districts, especially the Chhattisgarh. Similarly, the property tax management system which they have established in Telangana. I think these are examples how states have become proactive in implementing some of the space-based services. And I will urge each state to look at how you can establish regional remote sensing centers wherever it is not existing, and how the states can come stronger with connect with the Department of Space to establish such services. Specifically, I would like to tell you in the northeastern states of eight of the northeastern states, there is a specific thrust by Government of India to look at how space application can really be pushed, and we have almost 110 projects at hand to drive them. Some of them include crop intensification as well as remote monitoring of various natural resources. Also to tell that in the governance side, we have a portal called Bhuvan, which many of you may be knowing, may not be knowing. I urge you to go and search and find out how we are providing data and information for states for their various activities of governance, urban planning, geotagging, geofencing, asset monitoring, mining, natural resources planning, crop management. And wherever there is an opportunity to do that, we will be happy to work with the states to give better, specific state-driven services. Next slide, please. Now, coming to other domains of space, I think all of you may be keen, many states are very keen to set up their own space parks. And really, many of you really not know what exactly you want to do with a park and whether you can build rockets, satellites, or everything there. But I would like to urge you to look at what are the specific strengths of each of the state and which domain that you need to create that type of capability. And based on a theme, if you build a space park, really it can grow. You can create incubation centers connected with the regional academic centers, which are already, I just showed. Technology incubation centers can be created. Essentially, I'm talking about flourishing a digital economy. Basically, you know, the software industry in India is one of the biggest. It has an almost 8% of the GDP it is providing. And we have satellites and data-driven economy coming from space. If you merge them together, we will definitely go to a digital solution technology provider of the world in the future. Keeping this in mind, we would like to stress on various aspects that state can work in, especially in the STEM domain, teaching courses in space technology, science, engineering, etc. Upskilling the labor, which has ability to build high-tech products in your state. Tele-education program, which we would like to support. Support in the case of smart city programs, which are coming in space, is one of the important enabler for it. Probably the data reception centers, data processing, export related to this data process data, etc. can be created. Even data analytics solutions based on space-based data and value-added products we can provide. And I would like to tell you, the Department of Space is interested in creating institutions and establishment from north to south of the country. We have establishing a spaceport at Kulasekharapatnam in Kanyakumari district, and also the Satish Dhawan Space Center at Jammu Kashmir in the recent times. So with this, let me conclude and tell you that we would like to bring down the gap that exists between state and the space has been all over a central agenda all throughout, which is spearheaded by the Department of Space, but it is opening up, and we are bringing in new actors, specifically the young people, industries, and startups who are interested in space ecosystem to come up everywhere in this country, especially driven by the initiative of each of the states. Thank you so much.
So friends, you heard the 6 very information and action-packed presentations. It may need some time for you to absorb, but you got the hang of it, that how the 6 departments, 6 presentations told you what they have been doing or they could be doing for states. Of course, in this session, in our title, we had also written STI Vision 2047, which may not have been covered in so much detail because it is difficult to do justice in this 7 minutes to both aspects of this session. But when there are specific questions, or if any of the panelists want to add few words like the key 2047 mission, that could be one way to look at it, because many of the things which they said will lead to 2047. So, so now first, before I ask panelists to intervene, can I see if there are raised hands who would like to ask questions? Yes, please. Sorry, can you please shut up? Hello? Can you please ask them not to talk so loudly?
Good evening, sir. I'm Neeraj Prasad, Special Chief Secretary from Government of Andhra Pradesh. Now, first of all, I must congratulate all the secretaries for a very detailed, in-depth, illustrative presentations. But as you said, sir, we just got a feel of it. It's more of a, we just got a sense of what has been done and what are the potentials. What my request would be that either each secretary have separate meetings in which we can have the detail, and they can also tell us which all departments they would like us to call along with us and have a more in-depth presentations secretary-wise, sir. It could be nationally or it could be regionally as felt appropriate, because we have been interacting with the small pockets, sir, but we don't have this whole picture with us. And if it would be available, I think it will be extremely helpful.
I think absolutely. This was just to whet the appetite, just to give you a glimpse of what all the 6 departments are doing, ministries are doing. But you are very right, you need more deep dive to look at each of them. So is it possible that we can have your presentations loaded on some website? Is it okay with all 6 of you to share that? So that will be also available to all of you. And then you can connect with the specific department looking at your requirement. So, because you have to really engage on a more detailed manner. So, thank you. Any other? Yeah, please. Can you introduce yourself and ask the question?
I am PLN Raju, Special Secretary to Government of Assam, Science, Technology and Climate Change Department. So I am also thankful to all the secretaries for wonderful presentation and insight into all the, mainly focusing onto the applications. So my main monitor those things. And then many times because of the Northeast, we get a lot of cloud cover and then we may not able to get particularly high resolution data. And then nowadays it has come such a way that...
Sorry, can you make your comment brief so that others can also... What is the exact question?
My question is monitoring of these plants when you plant and see that the growth of them. So we wanted to monitor those things. So we require a high resolution data. And when we contact Planet Lab and these things, they have their constellation of the satellites, but they charge quite high amount of these things, even for 2,000 square kilometers.
I think we got the question. Would you like to make?
I want from Department of Space it comes.
No, the idea here is the availability of high resolution data in high revisit and periodicity and also covering the entire country, which is a huge demand. We recognize that. But currently the number of satellites that we have to service in high resolutions are lesser. For example, 2 or 3 only. The plan today is that this being a demand-driven system, we are in the process of aggregating the demand from each of you, the states and the application sector, and build satellite accordingly. So in this process is currently starting, and we are already in the process of aggregating the demand, and this connect is from the ministries and departments. So that will be aggregated and it will be built and operated. So this is a plan, and we have a plan to do that. And also, you should look at the service providers which are available in the sector as well. It is not only the Department of Space. We are encouraging now the startups, the new actors to come and then provide remote sensing observational services. You can also look at them. There are many of them now coming up in India itself, building their own satellites and building their own platforms. And the coming years, I will see that the availability is increasing. Thank you.
Thank you so much.
Thank you. Thank you. Do I see any raised hands? I don't see any raised hands, but we'll close this session soon. But before I do that, I'll again request each panelist to give their closing remark, and in particular if they want to say beyond 247 is very bright. Other than that, what specifically they would like to add? Dr. Chandrasekhar.
I think, thank you, Professor Sood, for moderating this session. While I was talking to all of you, I missed few points, and also while the discussions were on, also when you pointed out that this is the 2047 session, I just wanted to, all of us to imagine how 2047 would look like to all of us. I think it's just impossible to imagine in 2000, when we were in the age group of 30 or 35, how 2020 would be or 22 would be. And now we are being asked to imagine how 2047 would be. Only I can imagine that maybe AI will take over all of us, and also the manufacturing industry would totally revamp. Today we are talking of batch processes, and suddenly continuous manufacturing, flow technologies, 3D printing, and I think the way factories would look like today would totally be changed. So whether all of us are geared up to see how 2047 would look like, I think first maybe we should conduct some internal exercise amongst all the states to ask the youngsters how they would imagine 2047, how the environment would be, whether petrol and diesel would not be there, and a water bottle, what we put on the table, is the fuel in the car, that electrolysis will happen, or a catalyst will crack the water and you start getting oxygen into your air conditioner, and hydrogen will go into the fuel. But I don't know how the 2047 would look like. And other one also, I wanted to share with you that this opportunity for me very rarely to interact with all the 29 state representatives, that DST work very closely with all of you on a program called Saumitva, which is trying to map all the Abadi villages and all that. So I also request you to connect the right teams that the Survey of India, which is working with you, would enable this program go successfully. And another colleague was talking on the climate change and the environment. Again, we would like to imagine whether the Arctic melting, which I think Ravichandran has been advocating, that it will happen sooner than later, and how are we going to handle the sea rise levels, and especially the states which are in the coastal parts. How are you going to move the people away from the coast, or whether you are going to really do something different to protect those coastlands has to be thought very seriously. Of course, to make the human resource available, DST is working very closely to make sure that women in science becomes an important character, to see that more and more women come into science and technology. And also many programs which DST conduct today, we invite all the states to participate with us, that the SC/ST programs, where we bring those underprivileged colleagues to come into science and also use the technology for their livelihood. I'm sure these interventions will make India a very sustainable planet. Thank you.
Thank you, Dr. Chandrasekhar. Rajesh, quickly, 47 in 2 minutes.
Yeah, just very quickly, I would just add to what, finally the 2047, obviously we will always look for sustainable, healthy future planet. And I think that's what tells you that the biotechnology has a tremendous role to play. If we actually look ahead from ourselves, innovative technologies have to play a very important role, and all of us realize that most innovation is going to come from early startups that are going to try and carry out activities. My only request to all of you is that it's likely that many fail, but I think we should call them not them failures, but in fact promote them to become serial entrepreneurs. And that's probably the way my request would be, in addition to what you're saying. Very often in the entire world, the entrepreneurs who have been successful are after a couple of failures of these activities. And I think as an India, in the nation, we should accept failures not as a failure, but in fact it's an achievement of success that you have tried to do innovative technologies actually. Once you do that, I think we'll have a lot more successes, and in fact this will grow in an exponential way. Thank you.
Thank you, Dr. Gokhale. Dr. Kalai Selvi.
Yeah, I will also talk in two directions. Number one is, as I told, once we never had any kind of an interdisciplinary courses like the way even today we have. So we never had AC mechanic or refrigerations as courses. But I think today we have to think very seriously to meet 2047, like the way it is being discussed, e-mobility and other things. Starting from school education, we have to introduce like courses like batteries, energy efficiency, artificial intelligence, machine learning. So all these things are to be incorporated right from the school education and at the diploma level, and then at the engineering or UG and PG level. This is one thing that I'm just making it as a suggestion. And the very important thing is, now everybody we are talking about what best we can do as a new one. The second most important thing is waste to wealth. So I think whether it is a solid waste or liquid waste, whether in the form of an organic waste, so whichever form, how best we can make the waste into utility. It is nothing but circular economy. I think if at all we are able to address circular economy, I think that is the greatest justice that we do for 2047. These are the two things. Thank you.
Thank you, Dr. Ravichandran.
Yeah, in terms of Earth system, I have 3 points to make it. One is from the atmospheric point of view. In the atmosphere weather prediction presently, we have only spatial scale of about 25 kilometers as a prediction. But what we plan to have is in 2047, it is a weather management. Not only predictability in the city-based or location-based to this one, but also weather management. Weather management means weather modification. That means where you want rain, there you can make a rain, or it can be used as a weather weapon, or you can use it as a weather suppression. Suppose I don't want now this Ahmedabad, I don't want lightning and thunder now, so we can suppress that. That type of things we are expecting, that is in the weather. And in the ocean sector, presently we have 4% of GDP is a blue economy comes from. But I think it has to go in double figure, and it has to go much beyond, because the ocean will provide a lot of energy which we are not harnessed, not only energy but also water and the minerals and metals. It is available in the ocean, is plenty, which we have not at all harvested, not only from our Indian Ocean but also in other ocean.
Thank you.
It is in the ocean sector. And the last one is in the earthquake. We can only monitor the earthquake, but we cannot predict but at least we can aim for 2047 on early prediction of earthquake. That's the three aspects.
Thank you, Dr. Ravichandran. Mr. Vyas.
Thank you, sir. In my opinion, India should try to become more and more self-reliant. That is the message which the Honorable Prime Minister is giving. DAE was forced to indigenize development because of variety of reasons. When I visit so many of the entrepreneurs, I find all of them are full of energy, lots of ideas, and to the extent possible, we should support the system so that we become as much self-reliant as possible. COVID has shown there can be suddenly a disruption. Occasional wars also indicate that there can be tremendous disruption. So if we are not self-reliant, large population like India may get into a problem. That's all I have to say. Thank you, sir.
Thank you, Mr. Somnath.
The dream of India in 2047 is to become the best country to live in terms of the happiness index of the human beings. Keeping that aspiration as one of the important goals of our country, I believe science and technology is the one which will make us to be something like that. And in which I believe the space technology has an important role to play. As I mentioned earlier, the digital strength that we have already established, the space become an integral part of that whole process. And I only urge at this time in a meeting, because it is a specific to discuss on the contribution of the states, I would like to urge each of the states to look at how you can connect with this more and more in terms of providing better governance. And if you identify domains that the space can support, I think we will grow together to become one of the most powerful country, technologically powerful country in this whole world. Thank you so much.
Thank you so much. I think you have heard the vision of our six luminaries. We will close this session thanking you all. And the thunder applause which you are hearing tells that it has been an extremely successful session. And we wish all of you all the very best and take advantage of what is happening in various departments. Thank you very much.
Thank you, Professor Sood, for moderating such an insightful and engaging session. Thanks to our esteemed panelists for their interventions, which are critical for setting future STI pathways in India. It is